All right. So today, um, I'm gonna talk to you about the seven different electric companies that we were given, and I want to talk to you about the what the best choice for us would be with our company. And I don't think we're gonna need a lot of electricity for our company. So, for this, I think we would be choosing like the least amount. I don't think we'd be using a whole lot of electricity, with our company, um, as it's not like we're probably not going to be using a whole lot of electricity. We'd probably need some for like a few computers, um, a few the lights and stuff. As we are a online paper company, we would be using a few computers for online stuff, just to be contacting our patients and giving them paper, and also the different lights around the building. So we had seven different electric companies contact us, and I chose five of these seven, and here were the company's prices. So the first electric company offered us 4.85 cents per kilowatt hour. Now, yes, it does. Yes, it actually is a fraction of a cent. It is not like $4.85. It is 4.85 cents. So just wanted to clear that up. The second electric company offered us 4.7 cents per kilowatt hour. The third electric company offered us 5.1 cents per kilowatt hour. The fifth electric company offered us 5.3 cents per kilowatt hour. And the seventh electric company offered us 4.99 cents per kilowatt hour, which is basically just 5 cents. Um, Now, I made equations based off of the info given, and these were, so y equaled the total cost of money per year. So on the y-axis, which is the that's the vertical axis, or the one that goes up and down, will be the total cost of money per year in cents. So it's not in dollars, it's in cents. And I will be converting the cents numbers into uh, dollars, so it's easier uh, to see the cost. And then x which is the horizontal axis, or the one that's just like this, which is the number of kilowatts being used. So here were the equations that I made. So we have y equals 4.85x, we have y equals 4.7x, we have y equals 5.01x, y equals 5.3x, y equals 4.99x, and that was all the equations I made. But that is not it. There's also the yearly service charge and maintenance. And for this, we have them listed here. We have the first electric company, which is $100 per year. We have the second electric company, which was $150 per year. We have the third electric company, which is $25 per year. We have the fifth electric company, which is $50 per year, and the seventh electric company, which is $60 per year. Now, of course, we have to put these into the equations made in the last slide, so we added them with the addition symbol. So instead of y equals 4.85x, it's actually y equals 4.85x plus 100. Um, Now, it is kind of hard to read this part with my webcam in the way, so I'm just going to like squeeze it in the corner here. Um, Now, of course, now because we want to make some deals from when the equations are equal, I used a few techniques to get these points. So we want the points where the equations intersect together and give us a point where one becomes cheaper than the other one, and that's where we want to see where all these intersect. So in the next slide, we will talk about one of them. So the first one I used was the substitution method, and you can see my work done over here. Um, Now, the first intersection point I got was by using electric company 1 and electric company 3. The intersection was 468.75, comma 2373.4375. I kind of don't remember how to say my decimals, so sorry if it gets a little confusing. Um, Now, basically, what that point means is that that when we get to 468.75 kilowatts per hour used, it costs us 2,373.4375 cents. Now, that seems like a lot, but actually, what it means is that if we convert the cents into dollars, it would actually cost us $23.73, so which is $23.73 after 468.75 kilowatts per hour is used, or kilowatt hours is used. Which that is, it's not really a lot, which is pretty good. Now, the second one I got was from Electric Company 2 and Electric Company 1. This intersection was 333.33 repeating and 1,716.66 repeating. This means that when 300, 333 kilowatt, wait, oh my gosh, all the threes are confusing me. 333.33 repeating kilowatts per hour is used, it will cost us 1,716.66 repeating cents, or $17 and 100 and or oh my gosh, $17.16. Now, sorry for the extra six there. That was a mistake on my part, but as you can see, this is the work I did here. It may be a little hard to understand with my terrible handwriting, but that's the work I did. Now, the second one I used was the elimination method. For this method, I took two of the electric company's equations, added them together as seen on the picture on the bottom right, and basically I just added them together, tried to get rid of one of the variables, which was x or y, and just turned it into this right here. Now, the first batch of electric companies I used was Electric Company 3 and Electric Company 5. This led to me getting to the intersection 86 point, there's a lot of numbers, 86.206897, comma, 506.89655. This states that after 86.206897 kilowatts per hour is used, it would cost us 506.89655 cents, or $5.06, which is not a lot. The second batch of electric companies was Electric Company 2 and Electric Company 3. This led to the intersection 403.22581, comma, 2045.1613. This states that after 403.22581 kilowatts per hour is used, it would cost us 2045 dot yeah 16 oh my gosh, I gotta reread that. 2045.1613 cents, or $20.45. Sorry for all my mess ups. All the numbers are just like boggling my brain. Again, here's the work done over here. Let me just, oh gosh, how do I, oh no, I gotta somehow shrink this again. Oh my gosh. Okay. It's kind of hard to see it over there, but it is there. I'll just there we go. Here we go. Oh, that's so much easier. I'll just move it up there. Anyways, so that's how that will work. No, I can't squeeze anymore. That sucks. Okay. Now, the last method I used was the graphing method. Now, because I just recently learned about this method, the answers may not be very accurate, meaning that they may not be correct, but I did them anyways, just to see if I would get anything interesting. The first intersection I got was from Electric Company 7 and Electric Company 5, which was 0, 60, which isn't a very chaotic number like the other ones, which meaning it might be good, but again, I did say that they may not be correct, which I kind of am suspicious about this one in particular because it seems a little off for the very simple number. Um, which I just think that it's kind of strange that it came out so simple. And I was at first thinking, oh, wait, that's the yearly maintenance cost as said in the slide. But now I think about that doesn't make sense because they would say 60 cents, even though it should be $60. So I think the thing is just kind of weird how it's laid out. But yeah, that's the only problem with this that I found so far. Um, but in simpler terms, we also have the second intersection, which was from Electric Company 1 and Electric Company 7. This got us the coordinates 200, 285.714, comma 1485.714. This states that every 285.714 kilowatts per hour is used. This will cost us 1,485.714 cents, or $14.85. So yeah, that's pretty good. I would say that's very good. Now, it may seem that we are done here, but we aren't. But because of this is because of amenities. For example, Electric Company number 5 gives us a 5% discount after being with them for 6 months, and after 3 years we get a 10% discount. This means that the price of the equation will change after 6 months. So for example, after 6 months, we have instead of 5 y equals 5.3x plus 50, it's actually 5.3x times 0.95 plus 50, which is the 10% discount. And then after 3 years, it's actually the 10% discount, which, as you can see up there. Now this means when I put it onto the graph, it stated that after 6 months, when 10 kilowatt hours is used, it will cost us 100.35 cents, or $1, which is really that's I say that's pretty good. Normally it would cost 103 cents, or $1.03. So it's a 3% off, or 3 cents off. After 3 years, when 10 kilowatt hours is used, it will cost us 97.7 cents, or 0.97 cents. It's basically the same thing. So I think that's pretty good. But we had to put it on a graph. We had to compare each and every one of them onto a graph just to show which one would go to lowest and show us which one will give us a better what you call it. Basically, I'll just talk about it in the next slide. So I don't know why it's cut off. It should not be cut off. Okay. Sorry about that. The stuff is cut off for like no reason. Hold up. I gotta fix that real quick. Why is it like... That is not right. That should not be over here. Okay. That is fixed. Crisis averted. Anyways, it is time to choose one of the companies. Now, in the first picture, which is this one right here, which is this one, you can see that the red line is the one that costs the least. And this line is actually the third electric company. As you can see right here, you can see the line, the red line being the lowest amount of money being used. But see, it might be obvious that we just choose electric company number 3. But if we keep following it, all the lines, you can actually see that the black line actually goes under the red line, which makes it the cheapest, which is at about the 150 kilowatt hour mark. This black line is actually electric company number 5 after 3 years of being with them. Now, it may seem even more obvious that we should choose electric company number 5, but first of all, that's it after 3 years. And also, if we keep going, we can see that another black line passes electric company 5 at about the 4,000 kilowatt hour mark. This black line is actually electric company 2, which is pretty crazy. It just kind of goes under it. Now it is kind of confusing that there's two black lines, but I can assure you that this black, so like over here, this black line that's way over here is electric company 3, or wait, no, electric company 5 after 3 years. And over here, this black line that's now over here is electric company 2. So now, after all of that, that means that finally the answer is set that out of all of these electric companies, the electric company number 2 is the best one for a growing company in the long term, as the black line slowly moves to this area and ends up being the lowest amount of, or the lowest, which would give us the lowest price possible. So that would be the best choice for us. Thank you for listening to this. And yeah, have a great day.